Hey you guys, it's Professor Vitt, and okay. Hey you guys, it's Professor Vitt. I'm going to run you through our logic module here today. Module has 5 parts: definitions, types of arguments, evaluating deduction, evaluating induction, and fallacies. Now the definition section is going to start, it's going to be a little dry. Bear with me as we move through the module. I'll flesh stuff out. So here we go. Definitions. Remember, logic is a discipline that's concerned with exactness. And so these definitions, as they're written, you should be real familiar with because they'll be asked of you on the exam. So logic itself is the study of argumentation. But unless I tell you what argumentation is, I haven't really told you much about what logic is. In our normal everyday lives, we think of an argument as 2 people yelling. So, excuse me, for instance, you could imagine me talking to you about, say, my wife and I having an argument. And as a result, I had to sleep on the couch or something, right, that night. That's what most people think of when they think of an argument. But in logic, we mean something a little bit different. An argument is a series of statements in which the premises support or guarantee the conclusion. So I'll give you a definition, an example of this moving forward, but I have to define some of the terms that exist in that definition first, okay? The word statement just means an expression which is capable of being true or false. A premise is a statement that supports a conclusion, and a conclusion is a statement that is supported by a conclusion. So now we've gone through all these definitions. Why don't I give you an example of an argument and then apply some of these definitions so you can see what's going on. All right, so suppose Professor Vitt is in high school and he hears about a great party that's going to happen. And he asks his parents, you know, gosh, I really want to go to this party. And Professor Vitt's mom says, no, you're not going to the party, right? Now, I would normally say, right, and maybe I'd throw a fit or something like that. But suppose instead I wanted to try and convince her by the use of logic that I should go to the party. I would probably write something that looks a lot like this. And I apologize, you can't quite make out this word over here on the edge, but I will read it out loud to you. I would say, Mom, number 1, everyone is going to the party, right? Number 2, I am an everyone. Thus, number 3, I should go to the party. So what I've presented here is an argument to my mother, and I'm saying, look, what my conclusion is, what I want you to accept is that I should go to the party. That's what I want you to believe. This is what I'm arguing for. Lines 1 and 2 are the reasons that I'm supplying in service of 3. In other words, 1 and 2 are going to support 3, and they're going to build it properly. They're going to make it so that you have to agree to 3. If you accept 1 and 2, Mom, then you're going to have to agree to 3. And so I say, number 1, everyone is going to the party. So I'm making a claim here about a number of individuals, in this case, every individual, and I'm saying everyone is going to be having this trait, right? Everybody has this trait P. Trait happens to be going to a party. Then in line 2, I say, I am one of the people who has this trait, right? I'm in everyone, I'm in this group, thus I should go to the party, right? Now, there's no way Professor Vitt is going to go to the party, but I can use that example to show you, look, notice that lines 1 and 2 are premises. They're supporting 3. 3 is our conclusion. Additionally, lines 1 and 2 are things that are true or false. Everyone is going to the party. Well, that's either true or false, right? In this case, it's probably false. I don't know that I'm going to the party. But a statement is an expression that's true or false. And there are lots of expressions that we have which are not true or false. So examples would include things like saying ouch. Right? If I say ouch, somebody wouldn't necessarily say true or false. Right? Now, if I said I'm in pain, they would say true or false. But I didn't say I'm in pain. I said ouch. And so, there are lots of things like this. When somebody says hi, they're just saying hi, right? They're not making a statement that could be true or false. You wouldn't say false, right? Hi, false. No, it wouldn't make sense. So logic takes place on statements. Logic applies to statements, and it applies to the relationship that exists between premises and a conclusion. All right, now there are different kinds of arguments. In other words, there are two ways, there are actually three ways, but there are two ways in which the premises and the conclusions can be related to each other, and these features break arguments into two categories. Arguments can be inductive, or arguments can be deductive. Okay, so now that I've covered, by the way, hello, I'm now in my office. I mentioned this later on in the video, but I was just here for the day, so I ended up having a little extra time. I'm going to go ahead and cut the rest of this video for you guys. But the thing that I want to focus on now is I've given you guys these sorts of dry definitions for what a deductive argument is and an inductive argument is. I want to try to give you examples of a deductive argument and examples of an inductive argument in hopes that this will allow you to appreciate or understand the difference. Bottom line is, if the premises guarantee the conclusion, then the argument is going to be deductive. But if the premises just support the conclusion, it's going to be inductive. So if the premises support the conclusion, they don't guarantee it, it's inductive. But if the premises are hardcore, it's deductive. Like, duh, right? Get it right. It's so obvious that it has to be true. Okay, so let's look at this argument here. We have 4 premises and a conclusion, 5. Let's look at our conclusion. Thus, the United States government participated in mind control during the Cold War. Okay, so we're going to need to look for to try to determine, gosh, is this going to be deductive or inductive? All right, let's go ahead and read our premises. 1. The United States government, I'm just going to say U.S. government, participated in mind control during World War I through propaganda. Okay. Number 2, the United States government participated in mind control during World War II through propaganda. Okay. Number 3, the United States government participated in mind control during the Korean War. Remember, this is just a premise, right? We haven't yet gotten into too much of this. Number 4, the United States government participated in mind control during Vietnam. Thus, the United States government participated in mind control during the Cold War. Okay. This is an inductive argument, and the reason why this argument is inductive is because if 1, 2, 3, and 4 are true, we're not saying whether they're true or not, but if they're true, they do make it more likely that maybe the United States participated in mind control in another instance too. It's not a slam dunk, it's not a guarantee, but 1 through 4 support 5. They make it a little more likely. How likely? It's hard to say. Now, I'm not here bashing the U.S. government, right? I love the government. I work for it. But this is just an example to try to show you how induction works. Very often people will pick different instances of events and then try to predict future events similar to that one in the unforeseen future. All right, let's try another one here. If the government participated in Polybius, then the government participated in mind control. The government participated in Polybius, thus the government participated in mind control. Polybius is an urban myth. It's a video game that was thought to control people's minds. And so in this case, if the government did participate in Polybius, then the government participated in mind control, right? If 1 and 2 are true, is there any way that 3 could be false? No, right? 1 says if A, then B. 2 tells you A, and 3 tells you B. Doesn't matter how you feel about it, 1 and 2, if they're true, necessarily guarantee the truth of 3. So this is what we'd call a valid argument. It's a deductive argument, right? There's no way to wiggle out of it. If 1 and 2 are true, 3 has to be true. Contrast that with this other example. 1 through 4 could be true, but 5 could be false. All right, let's look at, on the same screen, an inductive argument and a deductive argument. All right, on the top, Professor Vitt wears blue on Tuesday, period. Thus, Professor Vitt will wear blue on Wednesday. Well, does 1 support 2? I guess it could. If I've worn blue on Tuesday, I guess it means that it's, at least in some sense, more likely that I would be willing to wear blue, and so I might wear it the next day as well. It's not clear how much support 1 provides for 2, but it gives it a little bit. 1 could be true and 2 could be false. That's what makes this an inductive argument, right? Does 1 support 2? It provides support for it. Does it guarantee it? No, it doesn't. Let's look at the second example here in the red font. Number 1, premise number 1. If Professor Vitt wears blue, then he is wearing a color. Number 2, Professor Vitt wears blue. Number 3, thus Professor Vitt is wearing a color, right? If 1 and 2 are true, if my premises are true, then my conclusion has to be true. It doesn't matter how we feel about it. It's just the way that the world works, right? This is just deductive reasoning. We wouldn't know what else to make out of it. So here you see an inductive argument and on the bottom a deductive argument. An inductive argument is one where the premises support but don't guarantee the conclusion, right? Because I wear blue on Tuesday makes it maybe a little more likely that I'll wear it on Wednesday. But below in the red font, you see that if 1 and 2 are true, it's almost like a math problem. It forces 3 to be true. Okay. In a deductive argument, if the premises are true, the conclusion must also be true. The premises are, you're going to see, they're going to actually force a conclusion to be true in a deductive argument. Now, there are 4 kinds of deductive arguments. You might carve this up differently. I'm sure some people do. But generally speaking, this is just intended to give you an idea as to what deduction looks like in different contexts. So one of the contexts, or one of the branches of deductive reasoning is known as categorical logic or categorical deduction. Categorical deduction is really a discussion about groups of objects or logic on the categories of objects. So for instance, all dogs are mammals is our first premise. All chihuahuas are dogs is our second premise. And our conclusion is, thus, all chihuahuas are mammals. Now you notice that if you accept the premises, the conclusion must also be true, right? It doesn't matter how you feel about it, whether you think chihuahuas should be reptiles or not, whether it angers or outrages you. It's simply the way that the argument works. And so categorical logic looks at arguments that are in different forms but very similar to this. There's a branch of deduction known as sentential logic. Sentential logic is comparatively modern. The categorical logic that we just looked at was older. It's Aristotelian, but people still do use it. Sentential logic is logic on sentences or simple statements. So, for example, one of my favorite sentential logic forms of all time is modus ponens. And this would be an example of this kind of argument. If the car is red, then the car is colored, right? So if the car is red, then it has the property of having a color. The car is red, thus the car is colored. You notice that it doesn't matter how you feel about the car or how you feel about the conclusion that the car is colored. Maybe you really wanted the car to be invisible, right? It's just a matter of the form of it, or the structure of the argument that makes it the way that it is. And so logic is kind of an abstraction. It's generalizing and trying to find patterns of reasoning that are the best, or why certain patterns of reasoning are the best.
Surprise, I'm now at the office at school. I just ended up down here for the day, so I'm going to crank through the rest of this video. I hope you like the new outfit change. Okay, one of the other types of deductive arguments is called argument by definition. And this is just a fancy way for saying we define the terms to mean something specifically, and as a result of those definitions, a conclusion follows from premises. So Hypatia, this is a name right here you might not have seen before, and perhaps you had seen it, maybe in print. Hypatia was the last great philosopher of antiquity. Unfortunately, we don't have any of her remaining works, but philosophers know her. Most of them do anyway. Hypatia never married. And so she, being an unmarried female, would constitute being a bachelorette. This is just what we mean by the term bachelorette, right? So if premise 1 is Hypatia is a bachelorette, then the conclusion is, thus Hypatia is an unmarried female. The way to think about it is the word bachelorette just means unmarried female. That's what it means to be a bachelorette. I don't mean the movie or the TV show, right? So very often people will make deductive arguments that are true by virtue of the definitions of the terms. And in those cases, we call them a specific type of deductive argument. We call them argument by definition. All right. Now we're going to move on to inductive arguments. And a goal here for inductive arguments is the premises support but don't guarantee the conclusion. So this could be because very often in induction we go from specific instances to general instances. So for instance, I may say, gosh, on Monday I'm wearing a white shirt, and then the next Monday comes along and I'm wearing another white shirt. After a certain number of Mondays like this, you might say, oh, let's see, Professor Vitt has worn a white shirt on 5 Mondays in a row. Probably the next Monday, even though we don't know what it is yet, probably the next Monday he's going to wear white. Well, all the premises of that argument would be all the days where I wore white on a Monday, and the conclusion would be the next Monday he'll also wear white. Now, it could be that that Monday I show up and I'm not wearing a white shirt. This is a feature of inductive reasoning that makes it different from deduction. Remember, deduction is similar to math. It's very rigorous, and there's usually one right answer. In inductive reasoning, premises support the conclusion, but they don't guarantee it in the same way. And we use inductive reasoning most of the time. There are 3 kinds of inductive reasoning. Look, you could carve these up differently or treat them differently, but I'm going to go over them as is. There's inductive generalization. There's a statistical argument form belonging to induction, and that's usually when you sample something, right? You take a portion of it and you say, well, we sampled the portion. To what extent is the portion also true of everything else? And then lastly, there's something called argument by analogy. And that's when you say, gosh, these 2 things are a lot alike. So this one has this trait, this one has this trait, this one also has some other fancy trait, so this one might also have that fancy trait. For each of these last 2, for statistical and argument by analogy, I will discuss how to evaluate those kinds of arguments. Okay, here we go. So inductive generalization goes like this. This philosophy class sucks. Thus, all philosophy classes suck. This happens very frequently. I know it happened to me. I took organic chemistry once, and my assumption wasn't very different from the first premise here, right? I just thought that class sucked. I was no good at it, right? So I assumed naturally all organic chemistry classes were that way. Probably not true, but that's what I was thinking at the time. Okay, next up we have statistical arguments. These are arguments that tend to be, well, they're similar to polling, right? Whenever you're watching an election, they'll say, oh, you know, with a certain number of the precincts reporting, we project so-and-so as the winner. What this means is we're taking a portion of a bigger population, and then we're going to try and generalize on the bigger population on the basis of what we found out about a smaller portion of that group. So here we go. 77% of people think that candidate Wash will win the election. Thus, Wash will probably win the election. Now, the strength of this argument will depend upon how big our sample size is. Here, I haven't told you, 77% of the people think, well, out of how many people? Is this 77% of the people, and I've asked 6 people? right? And 4 or 5 of them think this. I mean, whatever the 77% number is. So when you're evaluating a statistical argument, you need to look at sample size. And in fact, this actually happened to me in an academic meeting. I was looking at something and I saw that there were these percentages between these 2 different columns. And I remarked to a colleague, Professor Herrera, oh gosh, I can't believe that this column is like 50% more than column 2. And he rightly pointed out, well, yes, but of course these percentages are meaningless unless we know the number of the samples, right? The number that we're dealing with. And so the more the better for purposes of evaluating a statistical argument. So the more members of a group or a population that you are trying to poll, the better. Another important feature here is sample diversity. How different are the people that you asked? If we're talking about this example involving wash, gosh, did I just talk to people who lived on my street? If so, that may severely affect how we, it may be that people in other parts of the city don't feel that way about people who live in other parts of the city may not feel as strongly about wash as a candidate, right? So the diversity of the samples, the more different individuals you can select, the better your statistical argument will be. And then lastly, sample randomness. How did you decide to poll the people that you did? Was it random? Did you stop at every house that had a 2 in it? The more random the sample, the better the sample will be, because the less likely you are to just pick on one small subgroup out of the whole sample. So these are 3 criteria here for evaluating statistical argument. Remember, sample size, the bigger the better. Sample diversity, the more different the better. And sample randomness, the more random you select these people, the better, because the less likely you are to get a subgroup. Okay, an argument by analogy. This is a very, very super duper famous form of inductive reasoning. And this is an age-old argument here that philosophers give. 1, the universe is complex. 2, a watch is complex. 3, a watch has a designer. Thus, right, this is our conclusion in 4, the universe has a designer. This is usually for people, this is a very intuitive argument, meaning it makes a lot of sense to them, right? It's like, yeah, I can kind of see that, right? Here's a trait, here are 2 things, this one has this trait, so does this one has this trait, so this one probably already does. But in order to evaluate an argument by analogy, you should really look at more than just how you feel about the argument. Usually when I present this argument, if we're talking about this very argument in a philosophy of religion course, we talk about whether or not this analogy is good or bad. And these are 5 ways to figure out whether or not somebody is really making a good argument by analogy. So the first one is, the more traits that these 2 things have in common, the better, right? It means that they are more similar. The more the relevant characteristics which are being compared to the characteristics in the conclusion, the better. In other words, let me give you an example where this absolutely falls apart, right? Suppose I say, John lives in Long Beach, Karen lives in Long Beach. John likes rap music, therefore Karen likes rap music. Well, living in Long Beach and liking rap music are not intimately linked, right? It's not like people move to Long Beach and suddenly say, oh, I now like this kind of music, right? There are people in Long Beach who absolutely love rap, and there are people in Long Beach who don't. So living in Long Beach isn't very closely related to liking rap music. But if there was a different characteristic, like someone belongs to, the Biggie Smalls fan club, okay, well, now you're talking about a characteristic which will almost by its very nature make it more likely that this person will also like rap. So that's number 2. Sometimes you need to check to see whether or not the characteristics that you're comparing are sufficiently similar. Number 3, the less known about the things being compared, the weaker the analogy. So this is right. And I guess the most obvious way to put this is, the less that you know about the things that you're comparing, or one of the items that you're comparing, the less you're able to say anything definitive about it. So that's kind of the straightforward reasoning there. Number 4, the larger the number of analogies, the better. So the more analogies you can draw between these two things, the better. And 5, the more narrow a conclusion, the better. Meaning, I'm not going to test you on this very much, but the more radical and far-reaching the conclusion that you're trying to make, the more evidence you're going to need to have it. And so when you're doing an argument by analogy, or you're evaluating an argument by analogy, you want to try and make sure that the conclusions that you have are narrow and focused. One another. In other words, if you understand validity, you will understand, well, that's not exactly true, but these are related features. It's easier for me to just explain the features. All right. Valid. Validity is a feature of a deductive argument. So if I ask you a question about an inductive argument, is it valid? You'll say no. Inductive arguments aren't valid. So let's look at this one. In a valid argument, the premises guarantee the conclusion. If Juan lives in San Francisco, then Juan lives in California. Juan lives in San Francisco, thus Juan lives in California. We know this is true because of how reality works. Here we go. He's in Long Beach, so he's also in California. It's just the way the world works. When an argument works like that, in other words, when the truth of the premises guarantees the truth of the conclusion, then you know that the argument is valid. That's a good thing. In other words, you're kind of forcing someone to accept your conclusion because 1 and 2 are true. All right. Now, notice that I can talk about 1 and 2 and say if 1 and 2 are true, 3 follows. But I haven't actually said whether 1 and 2 are true or not. Maybe Juan doesn't live in San Francisco, right? Maybe he lives somewhere else. When I start talking about whether or not the premises are true, then I'm talking about an argument being sound. So a sound argument is a valid argument. It's just got premises that are actually true. So one way to think about this, sound are sound waves that are out there in the world, right? And they come to you, music, right? Air conditioning sounds, everything comes to you from the world. Sound comes from the world. So soundness has to do with whether or not the premises are actually true. Let me give you an example of a sound argument. So remember, a sound argument is going to be a valid argument that has all true premises. So here we go. All flowers are plants. All daisies are flowers. Therefore, all daisies are plants. If you tell me that this premise is true and this premise is true, then 3 has to follow. So this argument is valid, and it just so happens that all flowers are plants is actually true, and all daisies are flowers is also actually true. So this is an example of a sound argument.
Okay, so now we're going to talk about how we evaluate induction. Now, we are going to have, in induction, remember, the premises will never guarantee the conclusion, but the premises will make the conclusion more probable. So a strong inductive argument is when the conclusion probably follows from the premises. I'm in the boys' room. That's in contrast to a weak argument where the premises don't make the conclusion probable. The conclusion probably doesn't follow from the premises. So let me give you an example. Every previous U.S. president was older than 40. Therefore, probably the next U.S. president will be older than 40. All right. Now, notice that our premise here is every previous U.S. president was older than 40. Okay. That definitely makes it more likely than not that the next U.S. president will also be older than 40. So this is a strong argument, right? The premises make the conclusion more than 50% probable. And hey, daddy's working, okay? Just give me a second. And then if you remember, it was one thing for us to say that an argument was valid. So in other words, it was one thing to say that the premises guarantee the conclusion. So we're doing the same thing in induction. We're saying, look, it's one thing for the premises to make the conclusion more probable, but then it's another thing to ask whether or not those premises are true. And so that's what cogency does when you're looking at inductive arguments. A cogent argument is a strong argument that has true premises. So a cogent argument is one where the premises make the conclusion more than 50% likely, and all the premises happen to actually be true. So this is a cogent argument. It's a strong argument with true premises, and it's the analog version of soundness. Hey, you guys, it's Professor Vitt. I'm going to run you guys through fallacies right now. So I want to start with this A and B here. The first one is called affirming the consequent, and the second one is called denying the antecedent. Now, these are the two weirdest fallacies for you guys because they're the two with the strangest names. All the other fallacies more or less make sense. The reason why these fallacies seem strange, or they have strange names, is that they're called formal fallacies. There's something wrong with the way that the argument is built. So any argument that is built this way will have the same problem, right? So here's what the fallacy looks like. Someone says, assume if P then Q is true, and assume Q is true, I'm going to conclude P. What does that look like? It looks like this. If Jerry likes John, then Jerry will call John. Okay, fair enough. Suppose that's true. Now suppose it's also true that Jerry called John. Could I conclude that Jerry likes John on the basis of 1 and 2 being true? And the answer to that is no, right? Because Jerry might have called John for some other reason. Think for a moment. I'll switch it for you. This is a formal fallacy, so any argument that I build that looks like this is going to be wrong. Suppose for P I say if I'm in P is I live in San Francisco, and Q is I live in California. If I live in San Francisco, then I live in California. I live in California, thus I live in San Francisco. No, that's totally wrong, right? If I live in San Francisco, then I live in California. I live in California, thus I live in San Francisco. Well, no, that just couldn't be the case, right? You could very well be in another city in California that's not San Francisco. And so affirming the consequent is when people take an argument that has a conditional in it, P implies Q, and they take the second part of the conditional and they say, okay, that part's true, so the first part of the conditional must be true. But that's not correct, right? So this is a formal fallacy. Look out for any fallacy that looks like that in the exam. Okay, next one is denying the antecedent. This is the last of the weird ones, I promise you. Denying the antecedent is similar to affirming the consequent, but instead of affirming the consequent, instead of saying yay to the second part, you're actually going to deny the first part. So here's how it would look. If I am Darth Vader, then I can use the Force. I am not Darth Vader, thus I cannot use the Force. Okay. Look, this should seem wrong to you, right? This argument right here could be true if Obi-Wan Kenobi said it. Okay, Daddy's working, sweetheart, okay? Thanks, bud. Okay, so here the argument is, if I'm Darth Vader, then I can use the Force. I'm not Darth Vader, thus I can't use the Force. Well, that's not true. You could be Yoda. You could be somebody else. So any argument form like this is going to be a bad one. So look, when you're doing your exam, stop and look and say, oh, this is one of these sentential arguments, right? Okay, and he's got some ifs and thens in it. I bet you it's going to be either affirming the consequent or denying the antecedent, and then shake it out from there. All right, false dilemma. This is an attempt to get an arguer to accept a conclusion on the basis of offering only 2 options, or only a limited number of options when there should be more. So this is a great, you see this all the time in political contexts, right? whenever you encounter somebody, you always think they're right. So, well, I don't know about you, but sometimes, right, I've been in my life where I've been engaged in a political conversation, say with my parents, right? And I say, my gosh, right? Is my mom too stupid, too ignorant, or too evil to believe this? Well, obviously it's my mom, right? And she's not any one of those things, but that's the first thing that my mind jumps to. We all have a tendency to some degree to do this. And so keep that in mind when you're looking at test questions. You'll have something like that, and it'll almost track that language exactly. And you'll know that, oh, there may be another option, right? Instead of my mother, Professor Vitt's mom, being too stupid, too ignorant, or too evil, maybe it's that she considers other factors, right? Or she has different values. She might look at the same situation, but her values are weighted differently, so her conclusions are different. It doesn't mean that my mother's awful or evil. It's just a feature of my mind when I'm arguing. So, okay, a little risky with the mom example. Appeal to ignorance. This is just straight up ancient aliens fallacy, right? It goes something like this. Gosh, how did these ancient folks build these pyramids? I don't know. It must be aliens. It must be aliens, right? This is a classic argument fallacy when you're saying, well, gosh, nobody knows anything for certain about this, so then I'm going to go ahead and try and say something certain about this. That's called an appeal to ignorance. Appeal to pity / popularity. I put these together because they're together on a handout, but the basic idea here is you're asking someone to accept a conclusion on the basis that the conclusion is very popular, right? So Pearl Jam is the best band ever. How do I know? Well, they're super popular. Okay, well, that doesn't make them the best band ever. What criteria are we using to talk about what makes something the best? That would be a way to figure out that question. Appeal to pity is very similar. You're trying to get someone to accept a conclusion on emotional grounds. So, for instance, suppose I'm rushing to work and I get a speeding ticket. And I say to the officer, oh my gosh, officer, please don't give me a ticket. My students have an exam today. I have 3 committee meetings, and I'm driving on a spare tire. Please, please don't do it. Well, look, whether or not I have a lot to do that day or I've had a bad day has nothing to do with whether or not I've earned a speeding ticket. I've earned a speeding ticket if I'm exceeding the speed limit, not, right? And nothing else matters. Nothing else is logically relevant. Now, emotionally, someone might try and make these things relevant, but remember, we're not concerned with our emotions at this point. We're studying logic. So the question is whether or not these things are logically relevant. Shifting the burden of proof. Absolute classic in the paranormal field. You get an arguer who would, rather than prove their own claim, they require that you disprove their claim. So an example of this would be, prove that ghosts don't exist. I think last time we used an example involving vampires, right? It's when you're trying to remove, the arguer is trying to remove their own burden of proof and push it onto you to disprove their claim. All right, appeal to popularity. We did already talk about that. Oops, look at that. Zoom, zoom. Whoa, text up in here. I guess I should have done that earlier for you guys. Okay, appeal to force or an appeal to fear. This is getting someone to accept an argument on the basis of fear or force. Great examples here, right? Say that purple's the best color ever. I'm going to smash this plane into a mountain. Okay, well, look, I mean, is this the way to get someone to be convinced that purple is the best color? I mean, you might have other ways of convincing them, right? You might explain that, you know, purple was originally the color of royalty, and it was a big secret for many, many years how to make purple dye. I mean, whatever your argument's going to be, right? You know, you should not accept a basis or conclusion based on your fear. If you've ever watched any presidential campaign ever, you'll see that most of the ads are or many of them anyway, are just appeals to fear, right? If you vote for clean, it's going to be the end of the world, right? Clean's going to blow us up. stuff like that. Another argument fallacy, appeal to tradition, appeal to ancient wisdom. This is when you try to get someone to accept a conclusion on the basis that it's been done for a long time, right? So you say, oh gosh, I'm going to keep on cupping. I'm going to cup so that I feel, I do. Well, why are you cupping? Because my family has always done it. Okay, well, maybe they have, but you should also find out if it's helpful to you rather than harmful. Is there any evidence for it? So there are lots of things that people do because they're tradition, not because they're right. You look at the United States, right? We had an economic tradition of slavery, and obviously that was incorrect, and that needed to be changed. But at the time, right, when people were fighting for their lives, when they were fighting for independence to enjoy the same rights that we all do, you can see slave owners saying, look, this is our way of life. We've always done this. Well, that may well be, but it doesn't mean we should continue to do that, right? That's why we have civil rights movement and stuff like that. Think about, I'm not soapboxing, but just an example. Think about women's suffrage. So women were able to vote in the United States in 1921. Prior to that, they'd never been able to. If women in the suffrage movement were trying to convince someone, right, hey, we should be given the right to vote, if their opponents had just said, well, we've always done it this way, we should just keep doing it this way, then women wouldn't have the right to vote, and we wouldn't have such a vibrant democracy. Okay, ad hominem abusive. I don't believe I quiz you guys on this one at all, but it's a personal attack. It's right here. So anytime you're having I don't even know what's going on here. Here we go. Anytime you're having a conversation with somebody and they insult you, you might as well consider yourself to have won, right? Because just personally attacking somebody does nothing to affect the premises or the conclusions of your argument. It's just a way to attack somebody. Okay, the next one that's important is the lottery fallacy. I'll just take a second on this one. Lottery fallacy is when someone says, oh my gosh, this is really improbable, so it must have been fate, right? Someone buys a Mega Millions lottery ticket, they win the lottery, and they say, oh, this had to be fate because I used my birth date. And wouldn't you know, out of all the numbers, the birth date worked. Well, no, you're asking the wrong question there, right? The question isn't, is someone going to win the lottery? Of course someone is going to win the lottery, right? That's different than saying this particular combination of numbers is going to win the lottery. Think about it. Whatever combination of numbers that you pick, every combination of numbers is as probable as any other for purposes of the lottery. So I remember a band interview years ago, and the guy said, oh yeah, every time it was the lead singer of some band, and he said, oh yeah, every time I play the lottery, I just do 1, 2, 3, 4, 5 or something like that. And the reporter was laughing and said, oh, that's so funny, right? And he said, well, I don't see what's so funny about it. And the reporter says, well, of course it'll never come up. And the singer points out, no, 1, 2, 3, 4, 5, 6 is just as probable as any other combination of 6 numbers. It's right. So very often people make this confusion. Look, just because something is very improbable, we can't work backwards from the probability of something to say that, oh, then it must have been designed or it must have been fate, right? It just doesn't work. So be careful with that. Ad hominem circumstantial. This is an example of the, the genetic fallacy that we covered earlier, but it's basically when you attack a position on the basis that it comes from a certain person or a certain place. So an example would be, oh, well, don't believe so-and-so, right? He's a priest. Of course he's going to say that. Well, just because someone is a priest doesn't mean that when they say something that's false. You'd have to look at the merits. Remember our prior example of the NRA bill. Same principle. It may be a good bill. You don't know. You have to look in the bill, right? What did the priest say? I don't know. We'd have to evaluate what he has said, whether it's true or false. You can't just say because it comes from a certain person, it's wrong, right? You can't say, oh, the professor said this, so it must be wrong. You need to know what they're saying. Okay. Next up we have begging the question. Now, there are two versions of begging the question. The first one is when you're using a conclusion to prove itself. So very often somebody will say something like, James von Prague can read minds because he knows what people are thinking. Well, wait a minute. When you look at what's said here, James von Prague can read minds. Oops, where are we here? Okay, he can read minds because he knows what people are thinking. But that's just saying the same thing twice, right? You're just repeating it. It's like saying, Professor Vitt is really honest because he always tells the truth. You're just saying the same thing twice, it's just you're not really giving anything. Now, the other version of begging the question, you'll definitely see this one on the quiz, is when you assume facts that aren't in evidence by use of a loaded question. So people say, oh, are you still going to go shoot up or attack the pick and save tonight? And somebody says, I was never going to attack the pick and save. And they say, oh, okay. When I was in court, this was my favorite thing to do, right, was to rule somebody. If you can get somebody ruled a hostile witness, they can only answer yes or no. So, there's the witness, they get out of bounds, and you're able to say, isn't it true that you left that time at about 9:03, isn't that right? And they can only answer yes or no. And they say yes. And you say, and isn't it true that you didn't call your mother before you left? And they say, well, I didn't, but, and they say, just yes or no, right? When you can ask loaded questions, it almost doesn't matter what the answer is. The classic begging your question is, are you still beating your spouse, right? It's a crowded room, there's a party, and somebody says, hey, John, are you still beating your spouse? And there's this hush, oh my gosh, right? If John says no, then it looks like at one point he did. If he says yes, then it's even worse. But the problem isn't John's response, it's in the question, right? And so very often people will ask loaded questions. Were you lying on your tax returns or were you lying in the court? Neither one. No, you got to answer, right? So, okay. All right. Fallacy of accident. We're not going to use this very often. In fact, we won't be using this in the quiz, but the idea is when people use a general rule in a specific case. So it's something like, it's wrong to stab someone with a knife. Surgeon stabs somebody with a knife, and therefore it's wrong for a surgeon to stab somebody with a knife. Well, no, not really, right? Because this is a different kind of case. Straw man, this happens very often. It's when someone attacks a distorted version of your position. I think that this happens a lot sometimes when you're trying to some extent, when you're trying to talk to somebody. I mean, I know I've had this happen where somebody who believes in the paranormal says, oh, Professor Vitt, you're just a skeptic. You're going to deny everything all the way. You're just, I could produce a ghost for you and you still wouldn't believe it, right? And I, the response there is usually the same. I would say I'm not denying that there are ghosts. I just don't think that the burden of evidence has been met to establish that they exist, but I'm not making the stronger claim that they don't, right? So very often people commit straw man fallacies, not because they're evil, but just because they genuinely do not understand what your position is. And so when it happens, you can say, oh, wait a minute, this is a straw man. This isn't my position. And by the way, now that you know what my position is, I'm sure you'll correct it, right? I'm sure you'll agree with it because, of course, that your objections to my claim were wholly unfounded because that wasn't my claim. Now come on over and believe what I believe because I have a good argument. Okay, that's straw man. Next up, we have red herring. Not going to quiz you on this one too much, but it's essentially when you confuse the issue. A red herring is a fish, and when you drag a fish along a trail, it'll mask the scent. Boom. That's what a red herring is here. It's when you are arguing with someone, rather than answer the question, you just confuse it. So somebody says, I think we should increase the speed limit to 95 miles an hour. And I say, oh no, I think cars are fuel efficient enough. We don't need to go to 95. Cars are very fuel efficient. They really are. I mean, they can go a long ways on a little bit of gas. Oh, what does this have to do with anything? I'm talking about the speed limit. I'm not talking about fuel efficiency in cars, right? That would be a case where you bring up something that's kind of related, but not really, and then you just move on. Appeal to authority. This has two versions. We've seen those both already.
Hasty generalization. This happens a lot. It's when you draw a conclusion from a small number of cases. So, right, so I've shown clips before in class, and you show a clip of, say, a magician, right, who does a trick and fools somebody into thinking that they're psychic. And, oh, it turns out it's just a trick, and the magician is just using marked cards, and then... Right, I once had a student see a trick like that, and the student says, "Oh, that's it. There are no psychics." Right? That shows it right there. And it's like, well, no, right? There could be psychics somewhere in the world right now. We don't know, right? It could be in Tibet or something, or someplace. You have to be careful. Our mind wants to generalize. It's a tendency that we have, and so we have to be careful not to overgeneralize. When we do that, that's a fallacy. Okay, false cause. This one has two versions. The first one is when we say post hoc ergo propter hoc. It's when one event follows another so that we assume that the first event caused the second event. So I've got an example here. I was sick, but then I did the cups on my back, and then 2 weeks later I felt all better. You know, you just cup your back, wait a couple, 2-3 weeks, and your cold will go away. Somebody might rightly point out, look, your cold might have gone away anyway, whether or not you cupped your back. 2 or 3 weeks for a cold, that sounds about right. So you need to be careful. Just because one event follows another doesn't mean one event is caused by another. The second instance is when people confuse that two events or two features are related with two events are causally related. So think about it like this. This is the all-time classic example. Most people who eat rice have dark hair. Thus, eating rice causes your hair to darken. Well, Professor Vitt better start eating some rice because he's going a little gray on the sides. Okay, look, clearly eating rice does not darken your hair. But it's still true that most people who eat rice have dark hair. Why? Well, it has to do with where people eat rice on the planet, right? Lots of people in China and India eat rice. And it just so happens that they have a genetic makeup that means they have dark hair. These two things are related, but one doesn't cause the other. And then there's one other version, of false cause. And that's when people point to only one cause when many causes are involved. Let me give you an example of this. The best way to think about this one is when you say, well, gun control is really the best for this one. Look, every time there's a gun massacre, typically what happens is gun control advocates say, we have way too many guns, the guns are the problems, we need to get rid of the guns. And then people who are Second Amendment advocates, they say, no, guns aren't the problem, mental illness is the problem. Well, clearly they're both operating with an incomplete picture. It is not just the prevalence of guns, and it is not just a mental health issue. This would be called a concurrent cause, right? You would need somebody who is mentally unstable and they have access to firearms, right? That you'd need the two things to occur. So the problem with oversimplifying a cause is that if you oversimplify the cause, you will never treat the cause to get rid of the effect. Does that make sense? So that's kind of the way that false cause works. Fallacy of composition and division, you're not tested very heavily on these two. They're a little involved, but essentially the idea is what's true of the parts must be true of the whole. This is the fallacy of composition. So a classic example of that would be something like this. Professor Vitt is just made out of particles, right? I'm just made out of little atoms, chemical molecules. Chemical molecules don't have any meaning, right? It's just a particle of oxygen or a particle of whatever it is, right? Dihydrogen oxide or hydrogen dioxide, whatever it is. Particles don't have meaning. I'm made up of particles, therefore I have no meaning. Well, no, maybe not, right? I mean, what's true of a part may not be true of the whole and vice versa, right? So the first part is fallacy of the composition, where you say, because all the parts have this trait, all of the things together have to have that trait as well. That's not true. And the fallacy of division is when you say, well, the whole thing has this trait, so the parts have it. Again, I'm not going to test too heavily on that, but it does come up from time to time. Okay, the next two arguments here involve word choice. So when you are speaking and you choose certain words, you can actually force people to accept a conclusion if you choose your words properly, right? If you cover your tracks or you color the language in such a way that it kind of forces people to accept things. So let me give you an example of a euphemism. I once had a student who worked in a convalescent home, and a number of her patients were in a vegetative state. And when someone would come to visit, say their grandmother or their son or whoever it was, they would ask her, how is grandma? And the response would be, grandma's stable. You know, grandma's been stable, and that's good to hear. But truly the response is, well, grandma's on life support. She's in a vegetative state. If I said the last two words, if I gave that last rendering, that would be emotionally upsetting. And it just wouldn't be appropriate, right? But you can see in that instance how just changing a word or two can completely affect the response from another arguer. So in a euphemism, you're using words to make something sound better. So you don't say somebody died, you don't say somebody's worm meat, you say somebody is deceased, right, or passed on. Dysephemism is when you take a nice word or something that's kind of neutral or good and then you make it sound worse, right? So this happens with, oh my goodness, this is wrong. I'll fix this for you guys here. Hold on. Okay, ta-da, ta-da, it's been fixed. Okay, so a euphemism is when you make something sound better. And a dysephemism is when you make something sound worse. So euphemism good, dysephemism bad. Okay, special pleading, we're not going to have quiz examples of that, but it's when you apply a principle to someone's case, but then you exclude your own, you make a special exception for this case. So this is sometimes called the no true Scotsman. It's when you say, oh, you know, Scotsmen don't play baseball. It's just not something that the Scots will do, right? The Scottish people. And somebody says, well, John plays baseball, and he's Scottish, and he says, oh, well, no true Scotsman plays baseball, right? It's like the idea is when you point to a counterexample, that they'll somehow just then create a special rule to keep that exception as an exception rather than to apply the rule to it. Don't worry, we won't be talking about it too much. And then the last is genetic fallacy. We covered this last time and I covered it a little bit earlier. But remember, the origin of a claim doesn't make it true or false. You have to look at the content. Now, the origin of the claim, the form of the claim, can tell us a lot about what's going on, but it doesn't tell us whether or not the thing is true or false. Okay, you guys, that'll do it for our fallacies. I would keep that list handy for whenever you're running the quiz. I think it'll help you quite a bit.